Started. Okay. All right. I want to thank everybody for coming today and helping us celebrate Sue Liebman's retirement and wish her well. Sue had actually asked if she could give a talk today, so that's what she's going to do. She's going to actually talk about it. Before we get into that, I wanted to give you a little bit of background about Sue in case you know her as well. I learned some things from going through this. Sue actually got her undergraduate degree in biology at MIT. She then got a master's in biophysics at Harvard before moving on to get a PhD in radiation biology and biophysics at the University of Rochester. So you're a biophysicist. I knew there was That's great. She stayed at the University of Rochester for a postdoctoral fellowship before moving on to a faculty position at the University of Illinois, Chicago, where she was at from 1977 to 2012, working her way through the ranks, and eventually being named a UIC Distinguished Professor. But then in 2012, she moved, and that's when we got to meet Sue. She moved to Reno. This was so she could be closer to her. 19. 19? Oh, yeah. Well, this would. Sorry. Okay.
I've been here about 15 years.
Okay. Okay. Very good. She came to be close to her kids who were in the Bay Area. So we benefited from that. And she's been here ever since, obviously. Sue's had a distinguished research career. Her research is focused, at least more recently, that I'm aware of, is looking at protein misfolding or folding as it relates to neurodegenerative diseases using the yeast model system. But that's not what she's going to talk about today. Something a little more personal that she'll talk about today. She's had a very distinguished career. It includes editorial service on a number of editorial boards from a number of journals, including Current Genetics, Prion Journal, Microbial Cell, as well as others. She's given a number of talks at prestigious institutions in this country as well as around the world. She's also, and what's I think is particularly remarkable, is her funding record. She's actually been continuously funded since 1977 and brought in more than $13 million in research funding. So that's pretty impressive. And she should be congratulated for that. She's received funding from a number of different organizations, including NIH, NSF, NATO, the U.S. Army, as well as the various foundations, including the Alzheimer's Association, American Cancer Society, and others. There's a huge long list. I won't go through them all, but it's quite impressive. And this includes receiving an NIH Research Career Development Award, and more recently, an NIH Miro Award. With all that money, she's also, as you might expect, been very successful at publishing. She's published over 100 original research articles, and that's in addition to various reviews and book chapters. So what she's going to talk about today is actually one of her more recent publications, which is a book that she's written. And I know it's very personal to her. It's about genetics, heart disease, sudden cardiac death, specifically as it relates to her family. So Sue, I'll let you take a few. Thank you. I just want to make one note. You probably noticed there will be a reception, so after the talk, please stick around. wish Sue well in her retirement and take over.
Yes, and there's raffle tickets. Write your name, put it in the bowl, and we're going to raffle off 3 books. So be sure to do that before you leave. So what I'm going to talk about today is a turning point in my career. And about a year ago, I got to write a little article about that, and I called it "A Life-Saving Revolution Delayed." Can you hear me? Is the microphone on? Okay. Yeah. Use it or it's okay? Okay. It's not okay?
I don't think
You don't think so?
it's on, but just might have to be closer to her.
Is this better? Yeah, all right. I'll do my best to be one-handed. Okay, so admit people. Okay. I have to admit people with mouse to Zoom. Okay. Why isn't it going forward? It went forward before.
You try keyboard. It's frozen.
Okay, so the story begins in 2008 with my 36-year-old niece, Karen, who was out the night before her death. That's a picture of her the night before her death with her new husband. They'd been married a little while. She got pregnant right away. They were thrilled. She was 36. They didn't expect that they were on top of the world. They're in downtown Brooklyn Heights. Karen had complained to her doctor that, when I walk upstairs, I get out of breath. And her doctor said, "You're 6 months pregnant. Everybody 6 months pregnant gets tired gets out of breath when they walk upstairs." And so it was a go. So the next day, they went out on the promenade and they stopped in a restaurant. And as they were getting up to leave, her eyes opened wide and she slumped down. And the ambulance was there. She was with her husband, and the ambulance was there within minutes, less than 5 minutes. It was very good. They were unable to start her heart. They took her to emergency. They were unable to start her heart. And both she and the baby died. There was an autopsy, and they actually found nothing, but they sent her heart away. And when it came back, the diagnosis was what they called idiopathic dilated cardiomyopathy. That's cardiomyopathy when we don't know why. But we knew why. My sister had dilated cardiomyopathy, her mother. And they had told us that that was due to a virus. That's the first I heard of something like long COVID. It was a complication of some virus. We don't know when, we don't know what, but that's what it was. Well, that's not what it was. By then I had been in genetics for 30 years. My own daughter was pregnant and I was terrified. This wasn't the first time. This wasn't the first time that I had heard of a sudden death in my family. My father, when I was about 6, we were going through family pictures, and my father told me about his brother. This is my grandparents, his parents. She was a dressmaker. And this is my dad and his older brother, Eugene. And he told me how his older brother died when he was 4, when his mother, my grandmother's dressmaker's mirror, those huge heavy mirrors, fell down on him and killed him. And this was a tragedy that walked through my family for over 100 years. We lived with that. And recently I've been looking into family history. So I got the death certificate and I looked at what were these injuries? And there were no injuries. He died of heart failure. So my grandparents didn't know about DNA, obviously, but they knew about heredity. They knew enough to know that other families weren't going to want to marry their children if there was a sudden death in the family. And so they made up this mirror story. They moved, they left town, they moved into a different place, and everybody believed this story for all these years. Nobody bothered to look at the death certificate. Okay. So with my niece's death, I became something funny, I became a medical detective. And I'd always thought that genetics was important for my career. It was important for my teaching, but I never thought of it as important for me, for my personal life. Now, I think that I became a geneticist because I was destined to help figure out what happened to my family and to help promote genetic testing. As a yeast geneticist in Chicago, I would go every month to the Chicago Yeast Genetics Club. And there, Steve Crone was also a card-carrying yeast geneticist, and his wife was Elizabeth McNally, and she is a genetic cardiologist. And so I decided to become her patient, and that's what I did. And she told me, which I agreed, that we didn't know the gene, but this was genetic, that there were dominant mutations. They knew a handful that caused this. She got my sister's DNA. She tested it. It wasn't any of those. She kept testing and testing for several years. Finally, she tested all these genes. It wasn't any of those. That's all they knew of at the time. And she said, you know, it cost $1 billion to sequence the first exome. But now, you know, 4 or 5 years later, it's a mere $50,000, and I've got a grant. I can sequence 5 of my patients, and I'm going to sequence your sister's exome because I want to find out what it is. And so that's what she did. And she found a splice site mutation in the FLNC gene. This is a gene that codes for filament C, a component of muscle and of heart muscle. But by then I had moved to Chicago, and I wasn't her patient. And she had moved from from University of Chicago to Northwestern, and the communication got lost. And so initially she didn't want to tell me because she wasn't sure. And eventually she never told me because we never communicated. Finally, when my sister died, I wrote to her and reached her, and I learned about her paper and looked up the mutation. And lo and behold, by then there was, well, let me first tell you, when I discovered her paper, the paper said in it that the sister, that's me, didn't have the mutation. I knew that wasn't clinical. I went and I got your clinical test, and no, I don't have the mutation. So I called my kids, and I guess I left that section. Yeah, I called my kids. So I left that section out. When I was working with McNally and we didn't know the gene, she said, even though we don't know the gene, you're at risk. So you better get an echocardiogram every year until we figure out the gene, because you might have it. And by the way, your kids and your nephew should do that too. So that guy over there said to me, my husband, don't tell the kids. We won't want to have babies. We won't have grandchildren. This is just a fluke. Don't let this go. So we debated this, and we came up with a compromise. And the compromise was the kids were 30. I was allowed to tell them. I could tell them everything, the whole truth, nothing but the truth, once. But I couldn't remind them in a month later, did you get that echocardiogram? What was that echocardiogram? I couldn't tell them the next year. Remember, you're supposed to get an echocardiogram every year. I wasn't allowed to do that. So when I find, now I've destroyed this. Okay, I think you can hear me. We'll just do our best. Okay. So I came and I told my kids, I don't have it. You don't have to do this echocardiogram stuff anymore. We're done. And my daughter was, oh, thank goodness. I worried about it every time I had a heart, beat fast. I was worried about it. And my son says to me, echocardiograms? Was I supposed to be getting echocardiograms? Oh, yeah. I remember you told me that. I went to my doctor, and the doctor said, does your mother have dilated cardiomyopathy? And I said, no, she's healthy. And the doctor said, well, if she doesn't have it, you can't have it. So unfortunately, there's not too much doctors need to know about medicine, but penetrance is one of them. And this doctor didn't know that. Didn't know that I could have had the mutation and passed it on to my children, and I could have not been sick yet or ever. So I started including that in my genetics course, real heavy. Okay, but we still didn't know if this was caused by a new mutation in my sister or something we inherited from our parents. So let's look at my family history. So this is my grandparents, my Uncle Eugene that I told you about, and my grandmother, the dressmaker, died in her sleep when she was 60 years old. They said it was a heart attack. Here's my parents, my father, their son, and my mom. She was always very frail and sickly, much more sickly than my dad. So it wasn't obvious to me who of the two carried the mutation until I learned about my uncle. My dad died suddenly when he was 66. They called it a heart attack. My mom declined an autopsy, so we really don't know the details. Then this is me with my children, and it's a few months before my dad died. We were at a bar mitzvah, and that was the last time I saw my dad before the day of his death. And this is my sister at that same bar mitzvah party with the bar mitzvah boy, my nephew, and she had been diagnosed with cardiomyopathy at age 56, and they blamed it on the virus. But she, with medicines, was able to live till 74. And then this is Karen again, the day before her death. Yeah, she died 28 years to the day after my father died. Exact same day, November 16th. So what McNally found was that my sister had this splice site mutation in FLNC, and we were able to get tissue from Karen, and she also carried that mutation. Of course, we couldn't test anybody else. So about the time I learned about our mutation, another paper came out that described FLNC. So this work with Elizabeth McNally was the first clear work that FLNC was a heart disease gene. And this other paper had 23 other families that had truncating mutations in FLNC and had dilated cardiomyopathy. The amazing thing was that 2 of those families had our exact same mutation. And here's the pedigree of one of them. You can see they had a 17-year-old son who died suddenly at 17. So why is it? So I emailed the authors. These authors were all over the world. I discovered that the author who had worked with these 2 families that had our exact mutation was in Israel. I emailed him and he said to me, these 2 families are Ashkenazi Jews. Are you Ashkenazi Jewish? And of course we are. So it seemed like this mutation was prevalent in Ashkenazi Jews. And so why might that be? And I'll just introduce you to the idea of a founder mutation. So the idea is that in 70 AD, we Jews were in Judea, and the Romans came and kicked us out, and many of us left and went all over the world, and a lot ended up in Eastern Europe. And here we are, grown and multiplied, and there's lots and lots of people, enough that rare mutations show up. So there's a rare mutation, nothing special, 1 in a million. Okay, a couple of mutations you've heard of in Ashkenazi Jews. But then what happened is about 500 years ago, there were a series of pogroms, and all these people got killed, leaving over about 500 survivors. Among those 500 survivors, some of them carried these weird, rare mutations. And now, when they continue to multiply and marry among themselves and have children among themselves, this rare mutation is no longer so rare. So that's a founder mutation. It's not unique to Ashkenazi Jews. French Canadians who are isolated culturally, Finns who are isolated geographically also have founder mutations. Okay, so At the time, the DNA database that was available was the inflammatory bowel disease database. So I looked it up, and lo and behold, our mutation was there, and it was in 1 in 726 Ashkenazis, and not in anybody else. So this is a screenshot I took at the time. It doesn't exist anymore. Now GNOME AD is all different. But okay, so 1 in 250 people have dilated cardiomyopathy in the United States. And so it seemed like maybe a large number of Ashkenazis who had dilated cardiomyopathy would have this mutation. And so I decided to do a little project, and I recruited 2 med students here at UNR. And the idea was simple. We'll find maybe 20, 30, 50 people who are Ashkenazi Jews who have dilated cardiomyopathy. We'll have them spit in a tube. We got help. And we'll PCR up just that little bit of that we know for this mutation. We don't have to sequence, more than 50 bases. And we'll find out if they have the mutation. There was only one problem. There are lots of Ashkenazi Jews, but people don't know they have dilated cardiomyopathy usually until they die. So we couldn't find people. We eventually did find, so here is little paper we wrote comment. We did find 7, and out of the 7, 3 had this mutation. So it is common among Ashkenazi Jews who have dilated cardiomyopathy. It was a frequent cause. So over the next few years, I watched in awe as the genetic revolution was taking over. And more companies were available to sequence genes for incredibly low prices. And I was quite sure that by now, it would be very common, and we would be having lots of people doing genetic testing, and we would be reaping the benefit of genetic testing in terms of saving lives and improving health. But unfortunately, what's happened is that, and I'm looking at the wrong slide here, but anyway, there's been an underuse of genetics. But before I go to that, I want to tell you about the 84 actionable genes. So there's about 25,000 genes in the human genome. We think about 7,000 of them, when mutated, can cause disease. But the American College of Medical Genomics has many committees, and they study these, and they've come up with the idea that this year we have 84 genes that if you have a mutation in one of them, there's something you can do about it. And so what they say is if you come across, if they're sequencing you for cancer and they come across this heart disease gene, they should tell you. You should know about it because there's something you can do. They don't say that you should go get sequenced. Why is that? It's a little bit of a disconnect to me. So there's 3 reasons that, as best I can understand, one of them makes more sense than the others, but I'm not happy with any of them. One is it's too expensive. Doctors don't know what to do with it. You're too stupid. When you get the result, you'll just worry about it and you won't do anything about it. So what's the point? And then there's the concern, if you're not sick and no one in your family is sick, maybe in your ethnic group, it doesn't have an effect. And that's a real concern, but that's not the main concern. Anyway, they're still debating this, and there's people on both sides, and you know where I stand. Okay. So I want to say that I'm very pleased to say that the FLNC gene is now on this list of 84 as a result of work done on my family and through our advocacy. Okay, so this is the sorry state of genetic testing now. About a little less than half the people who have cardiomyopathy have it because they have a gene that causes it. So everybody who has cardiomyopathy is recommended to get genetic testing so that their relatives can find out before they die and get treatment ahead of time. So what percent of the people who are supposed, 100% are supposed to get genetic testing? What percent? Currently, 1%. 1% in the United States are getting genetic tests who have cardiomyopathy. So why is this? There's a bunch of myths. It's very expensive, costs thousands of dollars. Well, nowadays it's $100, $200, and some often covered by insurance. It's very hard to order it. It's very complicated. It's easier than ordering a dress at Macy's online. Tests can be ordered, and genetic counselors will do they don't have to know genetics. I understand it's bad memory having taken genetics, but the genetic counselors will do the heavy work. Sudden cardiac arrest only happens to those with a known heart issue. That's not true. It can be the first symptom of a heart problem. It only happens to older people. No, it can happen at any age. Learning about a genetic mutation just causes worry. Well, the American College has told us that for 84 cases, that's not the case. There's something you can do about it. It can save and improve lives. So we know that genes are not the only thing that cause heart disease or cardiomyopathy. There are environmental factors, and here they are. But there are over 100 genes that do cause cardiomyopathy. And what we know now is that they work together. So if you have a bad gene and you have a little bit of environmental stuff, you're in bad trouble, or vice versa. So just because you know that somebody has diabetes, that's not an excuse not to do genetic testing. 1 in 5 of them will still have a genetic marker that's causing the problem, together with the diabetes. Okay, so now, when you get the results of a genetic test, if you're lucky for the gene of interest, they'll tell you that no problem, it's perfectly benign or very likely benign. If you're not lucky, they'll tell you, we know this is pathogenic. There's lots of people with that exact mutation and they're all sick. So it's pathogenic or likely pathogenic. But unfortunately, there's a lot of cases where we just don't know. And these are the variants of unknown significance. And that's a big area in genetics right now, trying to get rid of and categorize those genes. And I'm excited to say, I wish I was still in the lab, that yeast genetics is doing a lot of this heavy lifting. So I want to stress that family history, I think I've already stressed it can be tricky. You've got people like my grandparents who lie, and you've got people who have penetrance issues, so they don't look sick and they still have the disease. But so that's the main thing, is to tell you about penetrance in this slide. And this is a little bit of my argument for not relying only on people who have disease or people who have a history, family history, in order to do genetic testing. And so some of the data that makes me think, try to make a case for universal screening, is that 1 in 2 people with a BRCA mutation have no breast cancer history in the family. 1 in 5 people without a family history have genetic disease. 1 in 6 will have an actionable change in care if they get genetic testing. There's greater than 50 known hereditary cancer symptoms. 1 in 250 have a hereditary heart problem. And how does that compare with genetic tests that we do now for general screening? So we screen newborns for congenital hypothyroidism, where that a condition occurs 1 in 2,500. And we screen for galactosemia, where it occurs 1 in 53,000. So why do, what does doing genetic tests do for you? Why do genetic tests? Well, the first thing is, of course, if you pay attention to it and you get clinical follow-up, you'll get genetic screening to see if you have disease. You'll get treated if you eat early if you have disease, before that sudden death occurs, or before that cancer occurs. You'll have that. But of course, this doesn't help if you don't do follow-up. It not only will help you, but it actually, even if you have disease and you get genetic testing, it will help direct your therapy. So there are some diseases that have the same symptoms caused by different genes, and they're different diseases, and there's different treatments for them. And of course, it's very important to protect your family members. Once you know your mutation, other people can do cascade testing and find out if they have the mutation and need to protect themselves, or if they don't have to worry about it anymore and lift that worry. And young couples can think about pre-implantation genetic testing to be sure that they don't pass the mutation on to children. So here's one tool I have, not exactly this postcard, but something very similar from it, from Connect My Variant. And it helps you find relatives. If you know your genetic mutation and you register with them, they will help employ genealogists to help you find genetic relatives that you don't know that you can then warn. And so this is why I care. 4 generations in my family and 4 generations of wrong answers. The dressmaker, my dad and his brother, my sister, and Karen. Okay. So this takes me to my book, which is my response to all of this and my call to action for broader testing to save lives. Book list says that it's part genetics primer and part memoir. It's really the heart of the book is a family story. And it also talks about women in science. And I hope you'll consider giving it to someone you love. Maybe it'll save their life. For those of you who teach, when I taught genetics for 34 years at UIC. When I taught genetics, I recommended a book called Mapping Fate by Alice Wexler. This is Nancy Wexler's sister, and it's the story of them finding the Huntington gene and of their family dealing with Huntington disease. And I found that the students reacted to that book very differently, taught with me back then, very differently from reacting to a textbook. And it didn't just teach them genetics, but it taught them why it matters. And so if I've convinced any of you to reconsider or consider genetic testing, let me tell you that for you or for someone you love, that the barrier is a lot lower than you think. So everygene.com offers, even though it's not covered by insurance, because it's not clear that we want to recommend this, if you want it, you can get all 84 actionable genes screened for $199. You don't need a doctor, they provide a doctor. They've given birth to heartgene.com, which will now for free sequence anybody's series of genes that are the cardiomyopathy genes if you have a diagnosis of cardiomyopathy. All you have to do is tell them you have a diagnosis. You don't have to have a doctor. So these are 2 great things that are available for us. So with that, I'd like to open it up for questions, and be sure that before you leave, put your name on a piece of paper and put it in the bowl, and we'll pick 3 out for raffling off the book. And there may be somebody selling copies. She was supposed to come. We'll see, the bookstore. So questions? Yes.
Notice that you have like the genetic thing. You can actually request more data. We'll send you a raw data. You can actually screen that. I did that. And so the question I have is that gene in on those pictures?
No, the 23andMe is great to find that your relatives. It's great. It was great to help me find relatives, because that's what I did a lot of, try to find people. But they only sequence, I wish I had that picture, a tiny bit. They have a bit here and a bit there and a bit there. They're not sequencing the whole gene. They're sequencing the single nucleotide changes that distinguish ethnicities. Pardon me? That's right. They're not sequencing anything. They just have chips of tiny little bits. So when people tell you, I've had genetic testing, I did 23andMe 10 years ago. first of all, 23andMe is not genetic testing. Second of all, 10 years ago it's useless. So if you've had genetic testing, these 84 genes, there's going to be 87 next year. And you want to keep up with it. Now, hopefully, you'll be able to get your whole gene exome sequenced, and you won't have to do that. Doesn't change. And they can look at 84 genes this year, and 87 next year, and 95 the next year. I can't figure out how to do it, and I'm a geneticist, so whatever. They make it impossible. There's not a good site where you can do that yet. So these panels, but it will come. It will come. So thank you for that question. Yes.
Every gene, once you get the data.
There's a genetic counselor who will talk with you.
So they supply somebody to help you.
Yes, yes. If you have a problem, if it's all no problem, they don't want to talk to you. But if there's a problem, they have a genetic counselor. Yes.
That's a pretty good price.
It's a pretty good price. Yeah. Well, somebody's footing the bill. Yeah.
Family planning would be reasonable enough for the gene of the actual list, but that's not the case.
No, it's not. But they argue about it, and you can write to them. They have a committee, and you can write to them and tell them. So apparently, we got the FLNC on the list, and somebody wrote and said this shouldn't be on the list. There's not enough you can do, and so they argue about it. They lifestyle change isn't good enough. They don't want you to just eat right and exercise. That's that they want some real thing that you can do to get on that list. But you're right, family planning should be, doesn't mean you can't do it, but it's not what they're calling actionable, that they should let you know if by chance they come across it. So.
Who has access to the Mass General data?
So they have a whole long thing you can go on their website and see, and they say nobody has access and we destroy your DNA after we sequence you.
Because I remember the gentleman who wrote the book, The Gene, when he was asked what would he advocate, he said, until we have universal health care, he felt that privacy and limiting is essential because of the potential for the insurance companies to abuse the data.
Yeah.
I was shocked at this.
Well, insurance can't get at this data from here, but if so insurance for health doesn't matter what your genes are. There's a law in the United States, GINA, they cannot discriminate against you because of your genes for health insurance. However, for life insurance, we have to get that changed. That's not true. So, but of course, if you have cardiomyopathy, they're going to know about it. The gene isn't going to change it. But that fellow, he endorsed my book and he wrote a whole nice thing. So apparently he changed his mind enough to endorse the book, even though I have the opposite view. Mukherjee. Yeah. Yes.
You indicated that the gene that's affected your family is actionable. So if you're identified with that defect, what actions do they recommend? They
recommend you get not only echocardiograms, but also MRIs and Holter monitors periodically, and that if something is found, you start on medicine for cardiomyopathy or the arrhythmia medicine, and you get an implanted defibrillator if you have the symptoms, not just because you have the gene. And if it's bad enough, you get a heart transplant.
So it's like most of the sudden cardiac death is most commonly due to arrhythmia, so that's quite a
yes
situation.
Yes. Yes.
Has there been progress on the molecular mechanism of that?
Yes. So what we know is that it's loss of function. So Han was telling me in his company, they're working on turning on the good gene, not just for this gene, but for lots of genes. A lot of genes we're sick because one gene doesn't work and half of that protein isn't good enough. But if you can turn that on, you don't have to do genetic engineering to fix the bad gene. You just turn on the good gene a little bit more and you're home free. Thank you for that question. Okay. Thank you for the great questions. Thank you all so much for coming out. It's so great to see so many of you that I haven't seen in a while, and I hope we'll keep in touch.
Again, please stick around for the reception.
And sign up for the lottery. And pick up postcards. I've got postcards out there. I don't have the Every Gene because they keep changing so that you can take a picture of it. I have the poster out there and, yeah, thank you. Here, this one works,
I think the batteries went dead and you couldn't see the other.
but they could hear me.
No, it's fine. There you go. Thank you. Leave it on, because Camber's gonna come in and she's gonna, so she can save the recording.
Yeah.
So if you get out of it now, we'll.
It's 2 pence.
My question.
Right.
I thought that's. Just when she said, show the map. I took the it's just showed the map. Like all over the board. I see you want to get in a multiplier.
I suppose you.
The Ashkenazi mutation is in this group. Show my book.
You know, I
But-
mean,
but
because
many-
don't they
many
break up
pe-
groups as half
Many
locals?
have mutations in FLNC.
Oh.
All different mutations, not exactly.
I'm here with your book.
Oh, great. Abel's out there. To see you, thank you.
Yes, it is. They did much along with it.
That's it.
See you.
Sam's been a while.
Oh, family is. Transfer.
I'm gonna save this and I'll email it to you. Okay, so we have a lot. Yeah.
Let me stop the recording real quick.
You're a lot.